we're going to talk about how to solve absolute value equations symbolically. So far, we have been working a lot with absolute value function graphs and use graphs to get a lot of information. And for this lesson, we're going to focus on how it works through the symbolic representation and how we can use the algebra knowledge that we had before to help us solve this type of equation. And when we understand the absolute value equation, we're really thinking about if I have an absolute value equation equal to some positive number, there are really two possibilities that's happening here. So let's take the part A in number 1 for example. If we want to solve this equation, and I know the absolute value of my expression 1/3 x minus 4 is equal to 7. That really tells me whatever is inside the absolute value, there's one possibility that this is just equal to 7. So when I take the absolute value, it's still equal to 7. However, we also have the alternative possibility. So we can connect it by OR, which means that we can also have 1/3 x minus 4 is equal to negative 7. When that happens, when I take the absolute value, I still get a positive value as the answer. So in order to solve the absolute value equation, the first thing, once we have the absolute value part by itself, there are really two possibilities we can diverge into. And these are the two cases that we're considering, and the only cases that could be happening here. And if we want to solve this type of problem, this really becomes something that's very similar to what we did when we reviewed linear equations and when we talked about compound inequalities. We have different scenarios to work with, and we can just solve each scenario individually first and combine the results. So the first probability is just the expression equal to 7 over here. To solve it, we can go ahead and add 4 on both sides. To get that, we would get 1/3 x is equal to 11. And now if I want to get x by itself, I can multiply 3 on both sides. That would give me x is equal to 33. That's one possibility. Or alternatively, if whatever is inside the absolute value is equal to the negative value, the negative 7 in this case, I can still do a similar procedure. Go ahead and add 4 on both sides of my equation. And therefore, I would get 1/3 x is equal to negative 3. And with this, we can again multiply both sides by 3 to get x by itself. And therefore, x is equal to negative 9. So as a result, we can say that the solution for this equation is negative 3 or 33. And if we want to put things in set notation, we can say the solution set is 33 comma negative 9. We can just use a list to represent the solution we have over here. And just like when we solved equation before, feel free to use the results to plug into the original equation to check your solution as well along the process. And next, if we want to think about part B, it's a very similar scenario. The only difference is that if you look at the equation, we have the absolute value expression plus a number is equal to 1. When that happens, that's something we want to be careful with. The reason we could split the absolute value equation into two equations in part A directly is that I have the absolute value by itself already. Here I don't quite have that case. I have the absolute value plus 2 is equal to some number. And in order to go further from this type of equation, the first thing I want to do is to isolate the absolute value expression. And therefore I can just subtract 2 on both sides. That would leave me the absolute value expression by itself. And on the other side, we would have 1 minus 2, which is equal to negative 1. And this is something that I want you to catch pretty early on, and it's much easier to get into the habit of doing that from the very beginning rather than trying to correct yourself later on. As you can see, right now I have the case of the absolute value equal to negative 1. We know that's not possible because for all the absolute values, we can only have non-negative values. And because this is less than 0, we can say it's impossible to achieve that. And in other words, we can say there is no solution for this equation directly. We don't even have to do any further algebraic work. So here I'm just going to make a note and say it is impossible to have negative absolute value. And therefore, we would say there's no solution, or the solution set is the empty set. And that's how we would go ahead and solve this type of absolute value equations.